What's up everyone? Today we're going to discuss about the distributive property, and I'm not going to teach you how to use the distributive property here. I'm going to teach you how is the logic behind the distributive property. So we're going to learn the logic technically with the explanation that multiplication is basically repeating addition, right? There are many ways to think about a distributive property. I'm going to teach you with how multiplication is just repeating addition, right? Like with that explanation. So we know distributive property. This is basically we're gonna do with distributive property. So with distributive property we just say, oh, 2 times 50 is 100, and we say 2 times 9 is 18, and we say, oh, the answer is 118. Cool, that's basically distributive property. But we need to know how this is working at the very bottom. And it's not really nice by just saying the distributive property. Come on, how is that nice, right? Like we need to know what the distributive property means. So let's see what the distributive property really is. This video is not really algebraically heavy. We are just gonna explain this with numericals, and we're gonna add a little algebra so you guys can understand a little bit of distribution in algebra with example of a plus b the whole square. Okay, this is also applicable for the people who are not yet who have not yet learned algebra, so they will have a good idea with algebra and with distribution with algebra, right? So it's not very scary. All right, so let's see the explanation. So let's use the simple explanation of 2 times 11. You might know the answer like by just me writing it. Alright, I'm gonna change that into 2 times 10 plus 2 times 1, because to prove that that distributive property works, this is same. I'm gonna explain why it is same. Because I could have done this, right? I could have done this the distributor form and get this. I'm just gonna explain with this first. I think that's much neater to explain, so you will understand the thing with this fashion. Okay, let's see. We have 2 times 10. What is 2 times 10? 10 twos. Alright, let's write it down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. Now, you see that we have to add like one more 2. Alright, let's add one more 2 plus 2. Cool. We have 11 twos. We got right back to this. How did we calculate the 11 twos? Alright, let's see. How did we calculate that? Alright, we see that. Oh, there are 10 twos. Cool. There are 1 twos. Cool. Nice. So I say, oh, in total there are 11 twos. There are 11 twos. How did I calculate that? Let's see. I calculated like this. Alright. Did we just get right to the distributive form? Yes, we just use the distributive property right now by explaining that basically multiplication is repeating addition. We just got right back to it. And I say, oh, 10 plus 1 is 11 twos. I got my 11 twos. Now I want to get back and I want to see that 2 should be multiplied with 10. I want to see 2 should be multiplied with 1. So what do I see? I will multiply. I see 11 twos. I will just say, oh, I have 10 twos. I will just do that. I have 10 twos and I want that to happen, right? And I see, oh, those left. I left like 1 2. So I will add 2 here, right? I will add 2 here. Sorry, I'll add 2 here, basically just saying I have 2 times 1. I added 2 times 1. So that's what's happening. And with this, you can also say, oh, there I'll take this number 1, 2, 3, 4, 5, 5 tens, 5 twos, and I can say 1, 2, 3, 4, 5, 6, and I can say 6 twos. Okay, this is also valid. This is 11 twos. Nice. And I can also say this. I can say like 5 and 3, right? 5 twos plus 3 twos, and then again 3 twos, alright? 3 twos, and yeah, that's just 11 twos. So I want you yourself to explain this by yourself and understand the essence of it. Okay, I'm just going to teach you, and after that you need to think about it and understand this. Okay, all right, I'm gonna give you a small algebra, and after that we are gonna talk about this the algorithm of this thing. Okay, I'm gonna explain it slightly. I think I have an explanation. If you don't understand it, you can stop watching the video. All right. Before that, here's a question for you all: a plus b the whole square, which is this. Okay. Nice. Cool. All right. I'm gonna distribute this to this. Okay. A plus b b. Okay. Now I want you to explain yourself how this works with what we learned, and then if you are like new to algebra and you don't like the jargon a plus b, you're like you might be familiar with 5 times 2 or something like that. You're not familiar with something plus and that being multiplied with that. You can think like that, right? I can think of this as 5. It's not really nice because it might be some random other number. Like it can take any number. So it would be better to say with some other letter like n. Oh, this is v. Okay, so you can like simplify it and make it understand. So this is a factorized form. All right, and this is what I did with distribution, and I want you to understand why, and I want you to find the unfactorized form with it. Okay, so this is not just the people who learned algebra, it's the people who are going to learn algebra. It's going to be very useful, and it's very nice if you understand if you understood distributive property what we learned right now. You can do this and you will understand a little bit of algebra and a little bit of distributive property in algebra. Okay, that is nice, right? That's a little homework for you all. Okay, let's just remove this and let's try explaining this phenomena here. Okay, we have been doing multiplication like this, right? I myself will do it this way. Well, if you have 24 times 24 and you don't know, we just use this 24 the whole square, right? We would just use this, and there's a formula. We just did this, right? A plus b, and I told you to find it. We're not gonna do that right now. Use that formula and like substitute that stuff. It's just gonna use this that one we did with distribution, right? Like a smaller distribution like this, we did this, right? Same thing, I just did that. Okay, I just did that. Okay, let's explain this phenomena. All right. Right, 24 times 24. I'm just taking 24 times 24 because it's probably gonna be easy for me to explain. All right, 4 times 4. Oh, I just distributed. All right, that's nice. 4 times 4 is 16. Let's put 16 here, and I will put 16 here. And you might be thinking, oh, why did I put the 1 here over there? It's actually just the 10. Okay, this is 10 plus 6, right? I just put the 10 over there, and this understanding will help you a lot. Okay, so 16. All right. 4 times 2. What is it? 8. What did I get here? 80. Oh, is this wrong? No. That's in the 20, like in that 2 is in the tens place, so it's basically 20. So I multiply 4 into 20, that is 80. And then you might be like, what about the 1? You see, here, this thing is just saying that, oh, it's just 80 plus 6 plus 10. I have that 10. I have to add that to the 80, so I get 90 plus 6, which is 96. So 4 times 2, 80. 80 plus 10, 90. So I get 96. See the elegance? How cool this thing algorithm works. So what it's just saying is that, oh, I see that. Oh, I see that 4 is being multiplied first to this term, like to this term. Then I see that, oh, that's just one place, and if I get some number that's like 10 or above 10, I'll say, oh, I'll go to this place. So basically I'll add with that, so I don't have to add this, so I can directly get the added version of this. So pretty cool. Nice, we got that. And I want yourself to think and explain this after I teach you this, and see the explanation that fits for you. Okay, it's basically gonna be the same, but anyhow, explain this to yourself, and it's gonna be concrete in your mind and the brain. All right, now I see 2 times 4. Remember, this is 20 times 4. 2 is in the tens place. So it's just basically this 20 times 4. What did I get? What do I get 20 times 4 with? I get 80. That is nice. So I get 80 here, but I just say 8. There's a reason behind it, okay? Because 20 times 20, I'll get 400. See, 20 times 20, I'll get 400. See, there are 2 zeros, and this thing is like less, right? 20 times says 4 is I'm getting 80. There's 1 0, and this is gonna be 3 all pretty much true all the time, right? There will be only 1 0. So if there are more zeros in the next term, because 20 times 20, I'll get 2 zeros, and I can add this under this, right? Oh, cool. All right, that means 2 times 2, 4, and I see that. Oh, I just did that, right? 20 plus 400. Alright, 20 times 20, 400, and did what? 480. 480. So this is using basically the distributive property. So when you learn this in school, you were just using distributive property in a more elegant way. That's how beautiful this is. So I see that this is 96. Look, we got the same thing. Now we can add up. What is 480 plus 96? Oh, let me add that up. 6, 8 plus 9 is 17. If you don't know how this works, try explaining. Why that one vendor? Try explaining. And I get 576. Try explaining. I don't think there's a distributive property, but think like this. 400 plus 80 plus 90 plus 6. Try explaining with this. And try there, because I told you the distributive property and its elegance. Try finding the elegance here too. Alright? So I get 576. Cool. So this is pretty much how this algorithm works. It's using the distributive property, and the person who made this is amazing, because he thought there's 1 0 and there's a 1 0, and I get 400, and when I multiply this, I'll get only 1 0, and I can put that under it, right? I can put this under it. There's 80 and this thing, and I can do that. He has a great concept of mathematics. That's why some who made this, like, literally have a great concept in mathematics, and that is amazing. And I didn't check for starting this video who made this, so I encourage you to Google it, like who made this. I'm gonna Google this after recording this video. I'm gonna say thank you to them. Your conceptual understanding is amazing. It might be this might be developed in the ancient times, so it might be developed recently. I don't know. So if it is in the ancient times, if there's a name, cool. If there's no name, like it's literally too much ancient, and we don't know who made it. It's okay. So whoever made this, amazing, right? Amazing. They have a great concept in mathematics. So that's it for this video, and remember this thing, okay? Please try finding the unfactorized form with the explanation of the distributive property. Cool. Okay, bye. See you then. See you with a new video soon. Okay, thank you. Bye.